I'm sure you're all excited to learn even more about large language models thanks to that brilliant introduction by Matej. As we move forward now, we're going to cover a quick primer on what NLP is and some important definitions and concepts. Natural language processing is the field of study that considers what natural language is and how we can create models and computational programs to solve problems in natural language. Whether we study the topic or not, we tend to use natural language processing every single day. Whether we're typing something into our prompts in our computers or on our phones, NLP is used to give us autocomplete, to look for spelling, all kinds of things that you might not realize are actually in the field of natural language processing. Not all of these problems are being solved with large language models, but I think in the future we'll see many of these solutions being LLM-based solutions. NLP is useful for us as it enables us to solve a number of different tasks. This could be from whether or not the sentiment of a review that someone's giving about a particular product is positive or negative, if we want to translate from one language to another, or if we want to create a chatbot or some kind of interactive system that relies on natural language as its form of input. Natural language processing is the field that considers how to solve these challenges. Other use cases, like similarity searching, which we'll cover in Module 2, are also in the field of natural language processing, where we want to use a natural language input and have a natural language output. Similarly, if we want to summarize complex documents or find just the important pieces in a very long document, summarization is also an important component of NLP. Finally, text classification can be more than just a positive or negative review. It also can tell us what the certain genres are, what the moods are, and what is contained within the text. So you can see there's a lot of different applications that NLP is applied to. Let's talk about some important definitions. If we consider the sentence, "The moon, Earth's only natural satellite, has been a subject of fascination and wonder for thousands of years." Well, that's a pretty long, complete sentence. If we think about what that sentence is made up of, we could think phrases, words, characters. Those individual building blocks are what are known as tokens in natural language processing. Tokens don't have to just be words or characters or subwords. They're a choice that we make when we create our models. Tokens you can think of as the building blocks or the atoms of our NLP problems. A sequence, therefore, is a collection of tokens that's meant to imply a sequential listing of those tokens. If we consider tokens to be words, then a sequence might be an entire sentence or a fragment of a sentence. If a token is considered to be a character, then a sequence might be T, H, and E of the single word of the. The vocabulary, then, is the entire set of tokens that we have at our disposal for our particular model. This could be our vocabulary of words in the English language. It could also be a vocabulary of all of the characters that we're using to define our problem. This means that we can then classify different problems in NLP using these definitions. So if we think back to the translation task that we were trying to solve before, we can think of that as a sequence-to-sequence task, as it takes one sequence in and usually responds with one other sequence. Sentiment analysis, if we think of it as a classification problem, is technically a sequence to a non-sequence prediction, as it typically responds with either a token or a couple of tokens. Question answering is even more complex, as we take in a sequence of text and then usually we generate a large sequence of text that's non-deterministic, so that it's more of an open problem. Being able to classify these different types of tasks will be relevant further on in the course, as we will find that being able to evaluate whether or not a model is good or bad can be quite subjective and dependent on the task that you're solving. Now, NLP is, of course, a larger field than just text modeling. This course is going to focus on NLP as a text-based problem because there's plenty to cover in that area, but you should be well aware that NLP is much larger than just text-to-text problem solving. If we think about speech recognition, where we convert audible language into text or audible language into another audible language, if we think about image caption generation, the amazing tools that we've seen in the last 12 months from things like DALL-E and Stable Diffusion, and image generation from text as well, are all within the realm of NLP. Now, you might wonder, well, why don't we cover those things in this course? Well, text interpretation on its own is actually pretty challenging. We'll see that even as we dive into simple problems, just dealing with text on its own is complicated. In fact, if you think about your daily life and interacting with other individuals, just using language as it is in its verbal form is prone to a number of different challenges. Language can be ambiguous, the context can change depending on how you say it, where you say it, and when you say it, and there can be multiple good answers to a particular question or comment. We've seen in the last few years that the amount of input data that we're giving to these models is growing and growing. The model sizes are growing in part in the same way. We'll talk more about what the sizes of these models really mean in course 2 of this program, but for this course, we're really just going to take as read the fact that model sizes will grow and grow to become more accurate and performant. Training data, likewise, is something that we will look at in the fine-tuning module in Module 4, but we won't spend too much time on the details for this particular course. All of these are important as they inform the different types of language models that we'll talk about in the next video.